Hello friends, before we start for today's topic, let me give you a brief profile of EduPristine. We are international training provider for finance certification like CFA, PRM, FRM, finance modeling, business analytics, etc. We are authorized by CFA Institute for CFA, authorized by GARP for FRM, which is Financial Risk Manager. EduPristine is also authorized trainer provider of FPSP India and Premium for PRM and APRM. These are some key associations of EduPristine, where we have conducted trainings for specialized courses, namely financial modeling, fixed income analysis, finance for non-finance managers, reporting, HR analytics, and business analytics for accounting professionals. Some of our corporate clients include JP Morgan, Bank of America, HSBC, Accenture, EY, Credit Suisse. Not only big organizations, EduPristine has also associated with world-renowned institutions like NUS Singapore, IMC, IMI, IIT Delhi, ISB Hyderabad, etc. We have global online presence and existing classroom presence at Singapore, Middle East, USA, Mauritius, South Africa, and India. So guys, today our topic is heteroskedasticity. Now, if you have any questions, please let me know then and there only. And in case I'm going fast or slow, do let me know. Okay, so shall we start? Okay. Now, I'll not go into the theoretical part of heteroskedasticity because today's webinar is mainly for Excel, how to uh, how to find out heteroskedasticity in the data and how to fix it. So as you might know that there are many different ways in which you can find out if heteroskedasticity is present or not, and the most common is the visualization. Then how to visualize heteroskedasticity. So to start with, I'll give you a brief background about the data we have. Now if you see the screen, you can see that I have given with policy number, number of vehicles, average age, gender dummy, married dummy, average vehicle age, fuel type dummy, losses. Now this case study is about predicting the losses with the help of the policy owner owning number of vehicles, what's the average age of the policy owner, what is the gender, male or female, if he or she is married or not married, what is the average vehicle age, what is the age of the vehicle, then fuel type dummy, if it's petrol driven or diesel driven. So based on these 6 parameters we need to predict losses. Okay, now before we move forward, as heteroskedasticity is nothing but the variance is not constant, right? So we need to see if the variance is constant or not for different parameters. Now let's first calculate mean, variance and standard deviation of our loss data. Okay, now if I simply calculate mean, which is the formula is average in Excel, and calculate it, and then I calculate the variance, which is RP. Considering this is a population, I'll calculate this, and standard deviation as nothing but square root of variance. Okay, now let's say I'm not interested in the full data, I'm just interested in married dummy. So if the person or the policy owner is male or female, so first I'll apply filter. There's a shortcut for filter which is Alt DFF. Okay, I'll select married dummy, so I'll select female, and I got female selected. Now in this, if you notice, the variance has not changed. How can I observe that variance is changing? Okay, so the problem is that one thing I can go is I can take the married dummy, so the female data set, to another sheet and check what is the variance, or now calculate it again. That's a cumbersome process. Now there is a shortcut for this, that you can, there is a formula called subtotal. Now subtotal, what it does, it tells you, or it calculates for you the only part which is filtered. Okay, now when you apply subtotal, it gives you an option of, the first is that what you want to calculate. You want to calculate average, you want to calculate count, or you want to calculate variance or anything else. Let's say we want to calculate average. Average is nothing but 1. Then which data set? Okay, my data set is this. I'll close the bracket. I'll get 386, which is same as our previous answer. Let me calculate the variance. Variance for with the subtotal. Variance is nothing but this 11, comma the data set which is this, and which is same as the variance calculated earlier and the standard deviation. Now if I change my data set to only female, if you see, the numbers has changed. Now this is the variance for the married data set, and if I move to this unmarried, it changes again. Okay, then I select all, it changes again. If I select the gender dummy, which is male female, it changes again. So you can now see that the variance is not constant, it is changing if you change the parameter. Let's say average age, vehicle age 2.5, it changes. Average vehicle age changes to 8.02, again it changes. So it changes, so the variance is changing. So one thing is this, you can calculate like this. Second is visualization. In visualization, you need to draw the frequency. Now if we look at the loss data, if you look at this carefully, you might notice that this, what kind of data is this? This is numerical data. Is it continuous or discrete? It is continuous because it can take any value between two numbers, right? Because if you say it's 292.4305,792, so it's a continuous data. Now continuous data, there will be hardly any unique numbers. So for that, frequency distribution is a difficult task. So what we can do is we can create loss band. So we can say, okay, let's say if any loss lie between 200 and 250, I'll give a loss band of 250. So then it will count the number of losses between 200 and 250, and then we'll draw a frequency distribution. That will make it as a range data set. Okay, so as it's a continuous variable, in continuous variable we deal in ranges, not in numbers. In discrete we deal in numbers, but in continuous we always deal in ranges. So if you see, this is 203, it should show as a loss band of, this is 402, it should show as a 450, and this is 553, it should show as a loss band of 600, 292, 300. Let's see if we can do this or not. Now I want to make it to 250. So first what I can do is I need to make it a multiple of 50. So what I'll do, I'll make round up, because 203 I want it to show as 250. So I will round up. So I'll first make this divide by 50, comma 0, it will round to the nearest digit. So if I divide 203 by 50, it will give me 4 point something, and I'm rounding up, it will give me 5. And if I multiply this by 50 again, it will give me, okay. So let's see if we get this similar in the, so 402 450, 553 600, 292 300, 247 250, 385 400, what we expected. So I do this, and now I have got a loss band. Now for 250 there will be multiple entries. Earlier for 203.3195946 there was only one entry, so there was no use of drawing the frequency distribution. Now for 250 there will be multiple entries. So here I can see 250, this, then this, then this. So there are multiple entries for 250. So we can draw a frequency distribution. Now one straight way is to draw, to select the 250 and then draw, then select 300, then draw. Another simpler way is to go with the pivot tables. Okay. Now pivot tables is, we want to draw all these. Okay. So there is a shortcut for pivot table. Press Alt N V T. It will give you a option to create pivot table. Now we have selected the range for which we want to draw the pivot table. Then we want to, okay, where we want to draw it, new worksheet or existing worksheet. Let's draw a new worksheet. Okay. Now it gave us an option, we can draw here. Now we want to draw, let's say, average age. Okay, I'll select average age. We want loss band. Okay, and we want count. Now it is giving us sum of average. We don't want sum of averages, we want it in label, as a label. So now it gives us row label, that how many, what is the total sum of loss, 20 in the age group of 20.6, 2462350, right? And but we don't want sum of loss one, we want how many losses are there with 250 band, how many losses are there in 300 band. Okay, so I'll do this, I'll take the values to the row labels. Now it gives us, okay, within the range 20.6, 100 loss band has 8 losses, 150 loss band has 103 losses. Then we move down, so 42.4 loss age group has 150 loss band has 144, like this. It's again cumbersome that if I want to see 20.6, I will go here, and then I want to go to 42.4, I'll go there. I want to go to 65.1, I'll go down. Now to make it further simpler, what can I do? I can move average age to the report filter. It will create a new filter. Now it gives me average age all, but I just want to see 20.6 average age. I'll select 20.6. Okay, now it gives me only those loss bands which are in the age group of 20.6. so 100 loss band has 8 numbers of losses. Okay, now I can easily draw the frequency distribution. I can go to insert, column, draw column. It gives me this. I'll take this up, right? Now if I change this to 42.4, it changes the shape of the graph. I change the number again, it changes the shape of the graph. Now it means the variance within age group, average age group, is not constant. Okay. Now if I'm dealing with only one variable, which is average age, it's fine. Okay. But if I'm dealing with, let's say, gender dummy, so I'll deselect the average age, I'll select the gender dummy, I'll take the gender dummy to report filter. Now I select only female, this is the shape, and if I select male, this is shape. So again the variance is not constant. So instead of gender dummy, I want married, unmarried. Okay, so I'll take to report filter. I'll select unmarried. Okay, so the shape is changing. If I go to married, the shape is changing. Okay. But if you look carefully, when I'm changing the parameter, the graph is changing, but the heading is not changing. So how do I know that what type of, for what parameter I'm looking at the graph? Or if I want to compare multiple charts, I can copy this in any Word file or PPT file or any other Excel file and work on this. But if the chart, the value of the chart doesn't change, how can I know which, for which parameter this chart is? So there's a way to change this. So this is chart title. I'll select the chart title. I'll press equal to, and I'll select this, and I'll press enter. Now if I change this, it give me married dummy one. So I can copy this. I can say, okay, this is married people and this is unmarried people. I'll change married dummy to, let's say, average vehicle age. I'll take this to report filter. Okay, so if you see, again the heading is changing. So then I can copy this and say, okay, see, the variance is not constant, so there is heteroskedasticity, so I need to fix this. So that's the first part in which we have diagnosed that there is heteroskedasticity present in our data set. Now we need to fix it. Now if you have tools like SAS, or there are packages, you can directly fix it. Okay, so we are holding a webinar on how to fix heteroskedasticity on in R, so that will be on 25th. So but today we will be dealing with how to fix it in Excel. Okay, now in Excel it's a long process. In R, in SAS, it's a very short process. You can fix it quickly. Okay, so let's try to fix it here. Okay, so now after doing the predictive analysis, we have removed the number of vehicles. So that's a totally different story. We have already covered this in our one of our earlier webinars. Let's try to focus on how to fix the heteroskedasticity in this webinar. Okay. Now, to start with, first we need to understand for which variable we want to fix the variance. So, not fix, basically to make the variance constant. Now, let's say we have only two variables. One is male, female, and another variable we have, let's say it's a petrol driven and diesel driven. So how many combinations of policy holder we will have? We'll have male who drives petrol driven, male who drives diesel driven, female who drives petrol driven, and female who drives diesel driven. Okay, now we have four combinations. So we need to fix variance or make it constant variance for these four. Now currently this has variance 1, variance 2, variance 3, variance 4. All has 4 different variances. But we want to make it as variance, 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 and variance. Right? So the point is, we are not dealing with any male or female or anybody with the average age of 20 or anybody who drives with petrol driven. We are here dealing with a combination of these parameters. We are dealing with a person who is male, whose average age is 20.6, who drives petrol driven, whose average vehicle age is 12 years, and he is unmarried. So we are dealing with these. So we need to make different segments. Let's see how we can make different segments. So basically what we'll do, we will combine all this. So we can do like this, and this, like this. So we can combine all these to make one unique segment to see how many common segments we have and then work on those. Okay, so in our example of two variables we had four kind of variances which we want to make it constant. Okay, now to make it simple we'll use the concatenate part. Okay, so what I'll do, I will use concatenate, and we are dealing with average age first, then this. Okay, so it shows like this, and I'll copy the formula to this. In the last we don't want this underscore, and we will use like this. Now I will create the segment as concatenate again, this comma, this comma, this comma, this comma. So we have 5 variables. Okay, now this is the segment what we have. So we will create this for everyone. Okay, and first we need to take this also down. So we have a quite huge data set. It's around 15,000 data points we have, and sometimes this makes this Excel slow, right? Because Excel can handle only like easily like 5,000 data points, but yes, it can handle, it has many rows and many columns, it can still handle a lot of data, but it makes Excel slow. It depends on your laptop or desktop configuration also. Okay, now so we have created this. Now before moving forward we will see if there are unique data points or not. So here we go, we paste it here and we paste it here. To get the unique numbers or delete duplicates, we can go to data and we have removed duplicates. So I'll remove the duplicates. So there are 15231 duplicate values and only 59 unique values. Now it means we have var 1, var 2 and so on till 59, which we will need to make it var and var. Clear? Okay, so now there are two methods to which we can deal with. We can segregate the records for segments. We can make 59 tables because we have 59 unique values. Find variance separately, but this will take forever. What if there are 25 variables or 50 variables? We cannot handle it. But there is another method. We'll make use of a formula for to calculate variance, which is variance x equal to mean x power 2 minus mean x power 2. So this is the formula for calculating variance, because if you use variance from Excel it's not easy, because you need to create 59 different tables and work on those. Not feasible, not at all. So we can make use of this formula and calculate it quickly. Let's do it now. For this we need scared losses. Okay, scared losses will be this power 2, and we can drag this down. We got it. Now we need to calculate standard deviation. For that we first need to segregate, or basically make table for these segments. For that we can use pivot table again. Okay, so for pivot tables what I'll do, I'll select, we wanted losses, scared losses and segment wise, right? So we want these 4. So what I'll do, I'll go to insert pivot table, pivot table. Now let us do it on the existing worksheet. Okay, so I will do it on, let's say here, let's do it on 4. Okay, so now it gives me an option what I want, right? So I want losses, I want scared losses, I want count, I want segment, right? Okay, so what it gives us, it gives us for each row label. So again we have 59. If you see the count, it's 59, so we have 59 unique values. It's 59, and then sum of losses gives us, okay, within this what is sum of losses, and within this what is sum of scared losses, and how many are there. Now let's see what we can do about this. Now the first what we need to calculate is, it's a, if you remember the formula which we saw in another sheet, it was mean of x scared. So scared losses, the mean of the scared losses. So I need to calculate the mean of the scared losses. So what can I do is, I can make, so one thing is I'll go to that cell and divide by this. But if you see, it's a it looks like giant formula, because what it is trying to do is, it's trying to get the data out of the pivot table. So instead of that, what we can do is, I know that it's this sum of scared losses are in S column. So what I'll do, S6 divided by, and the count is in T column, T6. So what I'm doing, it's just, what is mean? Mean is the sum of the numbers divided by the count of the numbers. So here it's the sum of scared losses divided by the count of the number of losses. That will give me mean square of cap losses. Okay, it comes out 761676. Then moving to mean of cap losses. Now mean of cap losses is nothing but divide R6 divided by T6. Okay, so we got 258. Then moving to next column, which is square of mean. Okay, so we have, this is the mean power 2. Okay, then the variance is nothing but the difference between this and this. Standard deviation is nothing but square root of this. So we calculate this standard deviation for all unique segments. So you have calculated. Now standard deviation or variance is different for everyone. You can clearly see here that's different. So you want to make it same. So let's populate the standard deviation here for each segment. So we'll apply the VLOOKUP formula, comma. So we need to apply VLOOKUP against this. Here is the standard deviation. So I'll press F4, comma 11, comma 0, 94. I'll drag the formula down. So I'll go here and drag the formula down, and I got the standard deviation for each segment. Okay, now let's see one more thing. If you see carefully, it says standard deviation 0. Now standard deviation will be 0 in only in one case, when there is only one data point. So we cannot deal with this. So either we can delete this entry, or for now we can just make it 1, and then we will deal with this later. Okay, now standardized losses. Now standardized losses is nothing but its losses divided by standard deviation. Okay, I'll drag the formula down. Now earlier we were dealing with the losses. Now we will be dealing with only standardized losses, not with the losses. Okay, so now So we have got this. Now let's check if we have stabilized the variance or not. Okay. Now earlier we were checking losses variance. Let's move this to standardized losses. Enter. The variance is 41. Now this is for the total data set, not for the individual. Now let's select one. Let's say this one. What is the variance? 1 here. This one. Okay. Let me select anyone else. What is the variance? 1. Okay, good. Let me select any others. 1. So it has variance again as 1. Then I can select anything else. So let's select this. That is the variance 1. Okay. Now you see that we have made the variance constant for all data points, all segments, unique segments. Okay. Now if you check for female dummy, it's 38, and for male dummy it's 47. It's not constant for female and male because we are not interested in female and male parameters. We are interested in unique segments because we are not dealing with individual male or female. We are dealing with a combination of male, then gender, along with married, unmarried, average age, fuel type, and average vehicle age. So we are dealing with a combination of these 5 parameters. We are not dealing with the individual parameters. So we were concerned only about the unique segments, and we have stabilized the variance with these unique segments. So we don't care if it is not constant for individual ones. Okay. Now, okay. Now what we can do is, when you move from this to predictive part, which is the regression, and you get a equation line, please do not forget to convert this from standardized to the actual losses, because you are not interested in standardized losses, you are interested in actual losses. So moving from when after running the regression line will predict standardized losses because you have replaced losses with the standardized losses. But after getting the regression line, please convert it back to the losses, actual losses, and see what kind of loss you can predict with a unique combination. So that's how we fix heteroskedasticity. So guys, any questions? Hope this was clear. Before we end our session, just let me tell you what EduPristine is offering. We are running our business analytics program, which is a 4-day course, and the start date is 14th September in New York. There are different cities where we are offering in US, in Middle East, and it will cover from basics to advanced analytics. In this, we are offering introduction to analytics, data, and basic statistics, where we will be learning how to handle data, how to make data dictionary, and then theoretical understanding of statistics. Then moving to predictive modeling, then so from simple to multivariate linear regression theory, then actually regressing using Excel and R. So we'll be covering regression in Excel and then in R, so that you know how to predict both in both tools, Excel and R. Then moving on to logistic regression, what's the difference between linear and logistic. There will be case studies on auto insurance company and credit card department for linear and logistic regression. You will be preparing scorecard data for logistic regression. Then moving on to advanced part, which is chat card, You will be working on hierarchical clustering, k-means clustering, time series modeling, auto insurance company. Okay, so these are our offerings. So if you are interested, do let our team know. Our team will be contacting you with the details. So just to let you know, in case you join in next 2 days, there will be extra 10% discount for the courses. Okay, now, so guys, if you have any doubts, please let me know. If you have any doubts, we can still discuss. Otherwise, we'll end our session here. Or in case you find any doubts later for heteroskedasticity, you can always email us and we'll try to answer your queries. So I see one question from Mr. Sharon, that what to do exactly if there is only one data point, which we have faced. So if there is only one data point for a particular segment, so it's not that important, so we can remove that particular data point, or we can make it standard deviation as 1 rather than 0 to deal with that. So that's how we can go with that. Okay, so I get thanks from John. Great, it was great. Thanks you all for your patience. Any other doubts, guys, please let me know. So there's another question from Mr. Christos, that do we need to do all these steps in R also? No, actually in R and SAS there are packages. In those packages you have to just run the command and they will find if there is heteroskedasticity present, and if it is present, then we need to run the command to fix it. Okay, so it is very easy to fix heteroskedasticity in R and SAS. In R we will be covering it in our next webinar, which is on 25th of July. So please do not forget to attend that webinar. So it seems fine. So if there are no other questions, we'll end our session here. Thank you guys. Thanks for your time. Hope to see you again. Thank you. Take care. Bye.